Right. Good afternoon, Madam Amelia and Dr. AHGALYA. My name is Muhammad Madanish Mamazaki, and my friend here, Alvin. We are going to present our ISM assignment 2. So, without further ado, let's just proceed. Next slide. Next. Right. Our project for assignment 2 is we are developing an IoT alert system that prevent driver falling asleep during their driving due to suffering or lack of sleep, also known as micro sleep. So what our system do is they are providing a various mechanism that could help the driver uh, their driver safetiness during their journey, so they didn't involve in a critical accident during their journey to their workplace and or school or etc. So next. So here is our how our system will look. So first you can see is the sensor placement diagram for eye tracking and heart rate monitor. So on the top at the windshield you can see the eye tracking sensor. This will detect the how many times the driver eye blinking. So it will know in the system the more you blink, the more it will have this various like whether the driver is sleepy or they are distracted. So then it will send to the microcontroller unit to do another activity such as alert system. So the driver where they are having micro sleep and they will become more so they doesn't falling asleep during driving. And then on the bottom here you can see the heart rate monitor placement. So also this eye tracking sensor and heart rate monitor both are correlated to each other. So they both connect to the same microcontroller unit that will alert the system. Pass on the next slide. So here is the now we're going to show you the communication flow diagram between the system of our IoT design. So you can see earlier the eye-tracking sensors and hardware sensor. I said it will send once it detect any activity from the user, it will send to the microcontroller unit. Then what the microcontroller unit will send it to alert mechanism. So it will send like various alert like honking so the driver doesn't fall asleep. Then it will go to the cloud server for the data save the data for the history so driver can see. Next slide. So here is how our emergency alert mechanism works. So here is the flow chart. So let's just say that it detect the eye close of the driver. Then what we'll do, it will go to yes. If it yes, it will go to the is it the elevated heart rate? So yes. Then it will go to the alert. So depending on various eye close, there are various like alert system installed within our IoT system. Let's just say it is no, then it just going to go to the alert. Next. Now I'm going to talk about the software prototype and development. So for our system, we are try to make our system beneficial to our user. So to make our system works, we are using a various uh, simulated system or software to develop our prototypes such as Node-RED and Python for the AI logic-based system, and finally Figma to develop the dashboard for our user to track their daily activity of the micro sleep. Next. First is the Node-RED. What is a Node-RED in our system? Node-RED is a low-code visual programming tool that was used to simulate sensor data collection and logic flow. It consists of nodes that represent different components of systems such as input, which is the eye and heart rate sensors, then decision-making logic, and finally the output, which is the alert system, as we can see on the diagram beforehand. So this system include component with randomized values. Like I said earlier, it will detect how many eyes blink, like you blink, which allow the system to detect whether the driver is experiencing micro sleep and also the heart rate levels. Next is the function node contains the logic for micro sleep detection. similar to the what I said previous. And then on the output nodes, it will give the data like flashing light and audio horn alert upon detection. And finally, this system includes the dashboard node, which display the driver status, sensor data, and alert logging in real time. Next. Okay. Right. So next, uh, I will talk about the function node. Now I'm going to talk about the output nodes, which this system which triggers a visual such as flashing light and audio horn to alert upon detection. Let's just say that the driver is falling asleep. Then the eye tracking sensor will like blinking, and then the vehicle will like automatically horn honking so the driver didn't fall asleep. Then moving to the dashboard node, it will display the driver status whether they are awake or sleepy, their sensor data, and finally alert logging real time detection. Now I'll pass to my friend Arvin.
Hi, Dr. Galia and Amelia. I'm Arvin. Okay, now I'm going to present about Python. That is AI-based logic. We use Python to simulate how the microcontroller process the data. It checks if the driver's eye or heart rate goes beyond safe limits. If yes, it instantly triggers alerts. This let us test the system logic using AI without actual hardware. So the next slide is about Figma. We use Figma to design a user-friendly dashboard. It shows live data like eye closure, heart rate, alert status, and collection status. The goal was to make the interface simple, clear, and focused on function. The next one is about software evaluation. We evaluate our system in four main areas: detection accuracy, response speed, user interface usability, and scalability. This helps ensure it's suitable for real-world use in commercial driving. The next one is also about software evolution, that is about speed and response. Our test showed the system detects microswitch in under 1 second and sends alert instantly. Cloud Sync using HTTP and MQTT took just 1.5 to 2 seconds. This proves it works well as a real-time safety system. So the next slide, software evaluation also, but about scalability. The system can be used in many vehicles thanks to its modular design. It works smoothly with 20 plus vehicles and can be expanded further with cloud optimization. This makes it ideal for fleet deployment. Okay, the next one is about software evaluation, but final summary. Overall, our program is accurate, fast, and easy to use. It provides a cost-effective way for companies to prevent microchip-related accidents and improve driver safety. Okay, the last one is about conclusion. Okay, in conclusion, we use real-life data to build a system that can prevent dangerous microchip incidents. Python helped us simulate smart alerts, and Figma allowed us to create a live monitoring dashboard. Our system shows how modern tech can improve road safety. Thank you.
Thank you.